Welcome to the feedback video for assignments 6 to 8. We noticed that some of you are still working hard to finalize episode number 2, whereas some of you are nearly done with episode 3 already. So we've received 10 submissions, of which 9 have been shared on the Miro board, and we've seen some very clear, nicely condensed bill of materials and some first linear scenarios that were modeled in the circularity calculator. As always in this video, we will share an overview of the work that you shared. We'll address 2 examples more in depth and address 2 of the questions that you've asked on the platform. We'll end up with some key takeaways and a little bit about the upcoming assignments. But before starting, I want to acknowledge the great diversity of case products that we have this year. So it's ranging from 60-gram single-use products to 700 kilogram products. And if you haven't seen that video of the snowplow, please look at it at the Miro board. We have products from monomaterials as well as composites. We have business-to-business products as well as business-to-consumer products, and different materials between products, also bio-based materials. So that's very nice to look at. By looking at each other's scenarios, you can expand your takeaways. So we really suggest you to take a look at the Miro board and also give feedback to your fellow participants. Starting off with assignment 6, as I said, we've seen some very nice bill of materials. So some of you have relatively simple products, so you could list all the different parts, and some others are working on more complex products and needed to condense the bill of materials. Here you see the example of Tiemann that nicely condensed his bill of materials into functional components or modules. It's now very manageable to work with, so well done. Be aware if you condense different parts into a module that you may lose some of the accuracy in your indices, especially if you mix different materials. In general, we advise you to consider mixed material modules as not being recyclable, which Timo also did for the last 2 modules. The alternative is to split a module into the different materials so you can model recycling options more detailed. Next is assignment 8, where you modeled a current linear scenario. We here have an overview of some of the results that you shared. And you can see circularity, resource circularity ranging from 3 up to almost 30%. And if you look at the differences between the products, you will see that the products that contain many metal parts rank higher in terms of resource circularity. And that's because already some recycled content is contained within the metal-based materials. We're looking forward to the products that contain renewable materials because they may even score higher already on resource circularity. And if you look in more detail, here's the detailed image, you will see the yellow box using recycled content or renewable materials. That will already increase your circularity, even though it's in a linear model. But because the products are not yet collected to be recycled on high quality level, no value capture is yet generated in this linear model. Lizzie already showed how you can optimize potential improvement within a linear scenario by looking at the materials that she used. So on the left, you can see a circularity of 3% for the current model. And by replacing some of the materials with containing more recycled content, she increased the potential resource circularity to 8%. So nice work, even within the current business model. In Arno's example, you can see how much money is already wasted. So it's not just a waste of materials, but also waste of money. So by entering data on cost, sales price, and number of products sold, you can get a first impression of the amount of monetary value that is wasted in a specific linear scenario. Next up, we have 2 questions that were raised by SFA, which we think are interesting for many of you. And the first is about the term recyclable. So what exactly do we mean with that? So recyclable refers to the property of the material. So can the material be recycled at a high quality level? And with high quality, we mean that you could use it again to manufacture the same part as it was originally used for. Be critical when assigning properties recyclable and renewable to a material. Ask yourself if such a recycling process is actually in place, or whether you know of a company that can actually recycle the material to a high quality level that you can use again in your manufacturing process. For renewable materials, we advise you to check whether the material is certified as being rapidly renewable, to ensure that the material flow fits in a circular economy. An example is the FSC certificate for wood materials. Recycled content refers to the actual percentage of recycled material that is contained in the part that you use. So it's not a material property, but what you've actually realized in your product design. I hope that makes the distinction clear. The second question was how to deal with assembly costs. Because as you can see in the circularity calculator, it's addressed, the tool asks for the assembly costs on the product level. So these are the costs to assemble the different parts and modules into the final product. The tool asks this to calculate the potential value capture. Because in refurbishment, where the product remains largely intact, companies can capture this value. Whereas in remanufacturing, where the product is disassembled into the different modules or parts, this value is lost. As an advanced user, so you don't have to do this, but if you also want to include the assembly costs within the module, you have 2 options. One is you simply include those assembly costs within the manufacturing cost of that module. The second option is to include it within the overall product assembly costs. You can choose this option if you already think the module will be disassembled in a remanufacturing process, so that the value will actually be lost because you need to reassemble that module when remanufacturing. You can keep it simple and just model the assembly costs for the entire product. You can choose which option you want to use. So those were the 2 main questions that we wanted to share with you. And we have the following key takeaways. So first of all, even though we assessed linear scenarios, you've seen that there's some circularity already because of the use of recycled materials. And that's also a quick win, right? If you want to have a quick improvement without changing too much in the design of the product and not change the business model, you can already slightly increase the resource circularity. So those are the main takeaways. And we also have a tip for those of you that still are modeling circular scenarios, the remainder of episode 3. Also think of the changes in the design that are required to turn to a circular model. And you can also consider changes in the business model. For instance, when deciding on the collection rate, because for instance, a leasing model will generate a higher collection, higher returns of products than in the sales model. So think about these changes in material, changes in the thickness of walls, for etc., if you are modeling these circular scenarios. Those were the tips. I hope they are helpful to redesign your product. You still have a week to finalize assignment 9, where you model the circular scenarios, and scenario 10, where you interpret your findings and submit your 3 takeaways. Also, please save the date for Wednesday, June 29 at 4 Central European Time, where we will have the final webinar of this course. Of course, there's still more feedback videos to come, but please save the date. We're looking forward to see you there. Good luck with the finalizing episode 3 and see you soon.